Hello, my name is Ian Slayton, and I am a physical scientist in the Bureau of Ocean Energy Management's Office of Renewable Energy Programs. In this presentation, I will discuss BOEM's cumulative impact scenario for the Vineyard Wind 1 project. To help orient us on the context of creating a cumulative activity scenario, here is CEQ's definition of the term cumulative impact. The Council on Environmental Quality, or CEQ, defines cumulative impact as the impact on the environment which results from the incremental impact of the action when added to other past, present, and reasonably foreseeable future actions, regardless of what agency, federal or non-federal, or person undertakes such actions. Cumulative impacts can result from individually minor but collectively significant actions taking place over a period of time. This inverted triangle represents the different levels of reasonably foreseeable development we considered in the cumulative scenario. A bar usually encompasses the bars below it, but the lower bars will often be duplicative rather than additive. For example, Vineyard Wind 1 on the bottom, 800 megawatts, is already included in the 5.4 gigawatts of COP submitted and approved, second from the bottom. The previous standard for the scope of reasonably foreseeable offshore wind development was based on projects permitted and then added to that projects entering the construction permitting process. This time, we began by examining the greatest number of possible projects and then eliminated offshore development that would be unreasonable to consider based on lack of state demand or technical inability. The top bar is the total Atlantic offshore wind technical resource potential. This bar represents how much wind energy is available on the Atlantic outer continental shelf with present technology. Such a build-out is not only materially and physically impossible, but also the amount of energy exceeds the demand of the entire eastern United States. Thus, this level was not determined to be reasonably foreseeable. The next bar down is the technical resource potential of the Atlantic call, wind energy, and lease areas. Call areas have not been leased and are still being evaluated for whether they are suitable to be offered to lease. There is no guarantee that such areas will make it to the leasing stage. Therefore, evaluating construction on them is premature, and this level of development was not reasonably foreseeable at this time. The next bar down is state capacity commitments. While the previous tier system looked at development from a regulatory and project perspective, in this scenario we examine future projects from a state demand perspective. This number has grown over the last several months, but is currently about 29 gigawatts with recent additional commitments from New Jersey. This exceeds the technical resource potential of existing Atlantic leases with existing technology, and includes New York commitments that have been made in anticipation of future leasing occurring. Therefore, this level of development was not reasonably foreseeable at this time. The fourth bar from the top is the technical resource potential of existing Atlantic leases. State capacity commitments are not evenly distributed along the coast, and perhaps surprisingly are not tied to the existing available lease capacity within transmission range. For example, the state capacity commitments of New York and New Jersey exceed the technical resource potential of leases in transmission range. Also, there are going to be conflicts such as with cultural sites, historical sites, essential fish habitat, and navigation that will make developing the entire technical resource potential of existing Atlantic leases impossible. Therefore, this level of development is not reasonably foreseeable. The fifth bar from the top, and all those that follow below it, make up our reasonably foreseeable cumulative scenario. This includes any projects with awarded offtake, any projects that have entered or announced their intention to enter the permitting process, and of course any approved projects. Basically, if a project has a name, it is included. After considering all projects with awards, construction and operation plans, or that have been announced, there is still some state capacity left over that has not been awarded. This potential for additional future development beyond named projects is also accounted for and analyzed in this scenario. The state capacity plan commitment for existing Atlantic leases totals about 21.8 gigawatts. All Atlantic leases were considered for their potential for development based on states with offshore wind commitments in transmission range and contribute to this total. Leased areas with no associated project are assumed to be developed to the extent necessary for nearby states to meet their offshore wind commitments. Assumptions about details not yet known were made based on the best available information. frequently, assumptions err on the most impactful case for the purposes of fully capturing potential cumulative impacts of offshore wind development. Some of these maximum impact case assumptions are listed here. BOEM assumed that all announced project schedules and state goals are kept. In other words, BOEM assumes the most rapid build-out scenario. If schedules experience delays for any reason, development will occur more slowly than is considered here, and impacts related to timing, footprint over time, and concurrent construction will be less than considered in this scenario. BOEM assumes the parameters and associated impact producing factors of the physically largest turbine currently commercially available, which is a 12 megawatt machine. The 14 megawatt turbine now proposed by Vineyard Wind is physically smaller than the turbine considered in this scenario, despite having a larger generating capacity. In areas associated with another project that has submitted a plan considering a smaller turbine, an 8 megawatt turbine is considered. This is a higher maximum case because it will require more structures to be built to reach the same generating capacity as a project using a larger turbine. BOEM anticipates that turbine technology will continue to advance in the coming years, but is analyzing the best available information for existing technology. This scenario assumes that all issues surrounding vessel availability for constructing future projects will be solved. If the limitation in available specialized vessels affects future developers' plans, it will result in a slower rate of build-out of these projects and reduce the occurrence of simultaneous construction events, which would be less impactful than what is considered in this scenario. Turbine array layouts and density for all future development in the leases offshore Massachusetts and Rhode Island are assumed to follow a 1 nautical mile by 1 nautical mile east-west grid. Other areas on the Atlantic Outer Continental Shelf are assumed to have the spacing equivalent of a 1 nautical mile by 1 nautical mile grid in terms of potential capacity for structures, but the specific spacing and orientation will be determined in the future in consultation with stakeholders. The scenario assumes that all development in the existing lease areas on the Atlantic Outer Continental Shelf will utilize fixed foundations due to the relatively shallow water depth, and the impact producing factors considered for each foundation is consistent with the largest monopiles currently commercially available. To the extent that future development utilizes jacket foundations or gravity foundations, the net contribution to impacts will be less or similar for most resources. The scenario assumes that all transmission infrastructure challenges regarding onshore interconnection points and offshore cabling will be solved. Any delays or limitations to transmission infrastructure would either delay build-out or reduce the amount of development considered in this scenario. Most information about these and other assumptions that went into creating the cumulative impact scenario for offshore wind can be found in Section 1.2 and Appendix A of the Supplemental EIS. Appendices A and B in the Vineyard Wind SEIS consider the incremental contribution of the offshore wind cumulative scenario from the impact producing factors affecting each resource. Each resource has a table of impact producing factors that are defined in Appendix A and originate from a 2019 BOEM white paper that can be found on the virtual meeting webpage. Some impact producing factors have sub-impact producing factors to give clarity as to how that factor intersects with the resource. Prior to each table, there is a baseline account which describes the current condition of the resource. The table utilizes the impact producing factors to analyze impacts to the resource from ongoing activities, future non-offshore wind activities, and future offshore wind activities, the cumulative scenario itself. Future offshore wind-related intensity and extent of ongoing activities is described separately to demonstrate how the future offshore wind development contemplated within the cumulative impact scenario incrementally contributes to the overall future activities considered in the analysis. The individual contribution of the proposed project and overall conclusion on impacts to the resource by each impact-producing factor is then provided. For additional details on the impacts from the proposed project, please see the draft EIS. For more information regarding the cumulative impact scenario, please see the supplemental EIS sections referenced here or the cumulative scenario poster on the virtual meeting room webpage. We encourage you to review the other materials available on the virtual meeting room webpage, including information about BOEM's renewable energy leasing process and how to comment on the Vineyard Wind supplemental EIS. Thank you.